Now let's look at the third of a series of videos on dividing complex numbers. And in this video, what I'd like you to do is to work through these three problems. And as you work through these three problems, I want you to pause the video and work through the work through the problems, and then check your answers. The way you check your answers is once you start the video again, I'll show you the answers. So now, write down these problems and pause the video and work them out. Okay, hopefully now you've started the video again after pausing it, and you've worked through these three problems. Now let's look at the answers to each one of these three. So the answers that I got when I worked through this is the first one, this is my answer, the second one, this one. The third one, there's actually two different forms you get the answer. You could have gotten it like this or like this. Either one of these would have been perfectly valid answers. If these are the problems that you have, if these are the answers that you got, then I want you to stop the video here and you can move on. If you didn't get the right answers, then let's work through each one of these in turn and see if you can find your mistake. So on the very first one, we have 12i over 5 plus 3i, and we want to simplify it. And the way that we want to simplify it is that, see we have an I in the denominator, so we can get that out by multiplying by the complex conjugate. So remember the rule for the complex conjugate. The rule for the complex conjugate is that if you have a plus bi, then the complex conjugate will be a minus bi. So in this case, the denominator is 5 plus 3i, so the conjugate will be 5 minus 3i. Only the sign of this imaginary term changes. If you multiply the denominator by that, you have to multiply the numerator by exactly the same thing. So you multiply that by a 5 minus 3i as well. This, if you notice, this is just 1. You're just multiplying it by 1. So what I do, so I don't make a mistake, is I only multiply the denominator first. And if I do that, that's a FOIL problem. It's 5 times 5 is 25. 5 times a negative 3i is a minus 15i. 3i times 5 is a positive 15i. And 3i times a negative 3i is a minus 9i squared. I can immediately simplify the I squared, but I actually do something else first. Here we have a negative 15i and a 15i. They're like terms, so they cancel. So I get 25 minus 9i squared. But I squared is simply minus 1. So that's 25 minus 9 times minus 1. Or 25 plus 9, and 25 plus 9 is 34. I'm done with the denominator. I'm going to do the same thing with the numerator. The numerator is just a distributing problem. It's not a FOIL problem. So you have 12i times 5 is a 60i. 12i times a negative 3i would be a negative 36i squared. I squared is minus 1, so you have 60i minus 36 times negative 1, which is 60i plus 36. I'm going to rewrite it so that the real number is in front, the real part is in front, so I get 36 minus 60i. And now what I'm going to do is I'm going to break this apart into the real and the imaginary part. So I get 36 over 34 minus 60 over 34i. And that's how you do that problem. Now I actually have one more step, and that is I'm going to simplify the fractions. But let's look there and see if everything makes sense. We have an I in the denominator, so we multiply by the complex conjugate. If we multiply the denominator by something, we multiply the numerator by something, so we just FOIL everything out. Now once we get, I'm just going to move this up so we have a little bit more space. Here we have 36 over 34 minus 60 over 34i. We just simplify this. If you notice the 36 and the 34, 2 goes into both, 2 goes into both of those, and that becomes an 18 and a 17. And 60 and 34, 2 goes into both of them, so that becomes a 30 and a 17. And our final answer becomes 18 over 17 minus 30 over 17i. 30 over 17. that's our final answer right there. And it's written in the form a plus bi, where a is 18 over 17 and b is negative 30 over 17. Let's do the second problem. The second problem is about as hard a problem mechanically as you're going to see in this first part of Algebra 2. We have 6 plus 2i over 4 minus 5i. The first thing we do is we multiply the denominator by its conjugate, which is 4 plus 5i. And if we multiply the denominator by something, we have to multiply the numerator by something as well. Now at this point we've got two FOIL problems. That can get a little hairy, so what I'm going to do is I'm only going to work on the denominator first, and then after I work on the denominator I'm going to only work on the numerator. So the first thing I'm going to do is I'm going to FOIL this out. I get 4 times 4 is 16. 4 times 5i is 20i. Negative 5i times 4 is a minus 20i. And negative 5i times 5i will be a negative 25i squared. The 20i and the negative 20i are going to cancel, so then you get 16 minus 25i squared. And I squared is just minus 1, so you have 16 minus 25 times minus 1, which is simply going to be 16 plus 25, which is going to be 41. Now let's work in the numerator. Again, we have a FOIL problem. It's 6 times 4 is 24. 6 times a negative 5i is a minus 30i. 2i times 4 is a plus 8i. And then 2 times a minus 5 is a minus 10i squared. I made a mistake here, actually. If you notice here, this should be a positive there, right? That should be a positive, right? Because I multiplied by the same thing. That's a very common mistake, so let's be careful there. So that 6 times 4 is 24. 6 times a positive 5 is positive 30i. 2i times 4 is 8i, and that's going to be a positive 10i squared. So be careful. We're going to multiply the numerator and the denominator by exactly the same thing. Now we're going to combine like terms. If you notice, this is a 30i and that's an 8i. Those both have like terms. So you're going to have 24 plus 38i plus 10i squared. Now, I squared is minus 1, right? So I'm going to plug that in right there. So then I have 24 plus 38i plus 10 times a minus 1, which is minus 10, so it's 24 minus 10. So I have 24 plus 38i minus 10, or 14 plus 38i over 41. Now, this isn't the form that I want in, but I'm going to box that up just temporarily to see. That is a correct answer. It's just not 100% the way I want it. I'm going to move this up so that we can keep working with this. If we have 14 plus 38i over 41, I want it in the form a plus bi, right? That's the form I want it, a plus bi. So I want the real parts together, so that's 14 over 41 plus 38 over 41i. And that's going to be my final answer right there. Let's look at the third problem. Our third problem is actually quite a bit easier. And the question is, do we remember that it's quite a bit easier? So the conjugate of 15i, the complex conjugate, technically is minus 15i. And you could multiply it by that. And if you did that, you would still get the right answer. But since there's no a here, you can actually just multiply the denominator by I and the numerator by I, and it becomes a much simpler problem. So the denominator is just 15i squared, and which is just going to be 15 times a minus 1, which is just a minus 15. So I like to do that first. I like to just work in the denominator and then work in the numerator. The numerator is going to be a distributing problem. So that's going to be 7i minus 3i squared. And I didn't leave myself enough space, so I'm going to rewrite it down here. 7i minus 3i squared over 15i squared, and I'm just going to erase all this. The 15i squared, that's 15 times minus 1, so that's a negative 15. The 7i is fine. The I squared is a minus 1, so that's 7i minus 3 times a negative 1. Negative 3 times negative 1 is 3, so that's 7i plus 3 over negative 15. I'm going to rewrite that a little bit by putting the real part first, so that's 3 plus 7i over negative 15. And that's the correct answer. It's not really the form we like it in, right? The form we like it in is a plus bi. So we like to separate out the real and the imaginary part. So I'm going to write this as 3 over minus 15 plus 7 over minus 15i. And the negative I'll bring out in the front, so that's minus 3/15 minus 7/15 I. And that's an excellent answer there. We can actually simplify it just a little bit more. If you notice that the 3 and the 15, 3 goes into both of those. So a final answer could be minus 1/5 minus 7 over 15i. And that's how you divide complex numbers.